This is Mr. Anderson for Kellogg Community College for our second video of 5 that will go through Chapter 3, Section 4, Establishing Identities. And the first of 5 problems in this video, we're going to look at problem number 6 on my worksheet. We are looking at some FOIL problems, and when we do our FOIL, we can see that these are opposite. They're the same kind of, they're the same order. You know, cosecant, cotangent, cosecant, cotangent, but they're opposites. So what this means is that this is going to give us the difference of squares. So this is going to be cosecant squared theta, and then minus cotangent squared theta. And what makes this important is because you have your the part I'm skipping in the FOIL is that I am not multiplying my O and I cables because they're going to be opposites and they will simplify to 0. So this first cable makes my cosecant squared theta. This last cable makes my cotangent squared theta. But the middle two cables I'm not showing are negative cosecant cotangent and our positive cosecant cotangent. Now I will take our cosecant theta and squared theta, and I'm going to write the equivalent expression of cotangent theta plus 1. So this is an equivalent expression to this, and I write down my cotangent squared theta. Cotangent squared theta minus cotangent squared theta simplifies to 0, and therefore my answer here is 1, which establishes this identity. Problem number 6 and 7 are very similar. Notice here we have another FOIL problem. 1 times 1 is 1. This is going to be cotangent theta, and this here is going to be cosecant theta. So now we're not seeing the same thing, but what could make my problem a little bit easier if I, instead of FOILed, if I looked at 1 minus cosine squared theta and saw that that was equivalent to sine squared theta. Because if I, again, look at my trigonometric identities, sine squared plus cosine squared equals 1, so therefore 1 minus cosine squared theta is equal to sine squared theta. Now 1 plus cotangent squared theta, that is equal to cosec. Think about the problem we just did up here. This is equal to cosecant squared theta. And you can see that sine squared theta times cosecant squared theta, I can rewrite this as 1 over sine squared theta. So sine squared theta divided by sine squared theta is 1. 1 times 1 is 1, and we just established that identity. There's a lot of situations where you're going to have these identities in front of you, and it's going to be very important that you'll start to learn them and learn tricks on how to do them. And this is a fun one, because what we're going to do is try to see what we can do with tangent and cotangent. And maybe take my first tangent squared theta and rewrite that as secant squared theta minus 1, because that's what tangent squared theta is equivalent to in secant. And then this would be multiplied by cosine squared theta. Plus, let's rewrite my cotangent as cosecant squared theta minus 1, and multiply that by sine squared theta. Now, all I'm trying to do is get this entire thing to break down into 1. So what's going to happen is I'm going to distribute my cosine squared theta to this binomial. So this gives me secant squared theta times cosine squared theta minus cosine squared theta. And I'm going to distribute this over here as well. So this is going to give me cosecant squared theta times sine squared theta minus the sine squared theta, and 1 is just sine squared theta. So what this means is that these are reciprocal. Secant and cosine are reciprocal functions. So I can rewrite my secant squared theta as 1 over cosine squared theta, but this simplifies down to 1, because I would have cosine squared theta divided by cosine squared theta, which is 1, minus my cosine squared theta. And again, look over here, I got cosecant squared theta and sine squared theta. That's going to give me a 1 as well. And then I have my minus sine squared theta. And what this gives me now is I got 1 plus 1, that's 2, and I've got my minus cosine squared theta minus sine squared theta. And in kind of a weird little twist here is that I can, because I know from my trigonometric identities that sine squared theta plus cosine squared theta is equal to 1, so I'm going to factor out a 1 from these two expressions here. So now I've got my cosine squared theta positive and my sine squared theta positive. So now I have 2 minus 1 times 1, or 2 minus 1 equals 1, and I've established my identity. Now don't freak out when you see the power of 4. Just think about your factoring rules. You'll notice that this entire side is written with cosecant. So I'm going to factor out cosecant squared theta from both sides, from just this piece right here, and this is going to leave me with cosecant squared theta minus 1. And I'm going to keep writing, keep trying to manipulate this to make it look like this expression over here. And we know that cosecant squared theta is equal to cotangent squared theta plus 1. And we know that cosecant squared theta minus 1 is the same, is equivalent to cotangent squared theta. And what that means is that I'm going to then distribute my cotangent squared theta to this binomial like so, and I'm going to have cotangent to the 4th theta plus cotangent squared theta, and that's what is equal to this side right here. So yes, we've established our identity, and it just was a matter of turning cosecant into a cotangent equivalent expression and distributing that back. And our final problem of 5 for this video here is we are going to try to get the left-hand side to look like the right-hand side. Now this one is going to be a little bit tricky, and I think what's kind of challenging is to maybe knowing where to start. And if you're lost at all, what you may want to do is try to get the left-hand side to look more like the right-hand side, and the right-hand side is written in completely sines and cosines. So let's rewrite our left-hand side here to look like sines and cosines. So this is going to be 1 over sine of u minus cotangent is cosine of u minus sine of u. What's kind of nice about that is we actually have a common denominator here. So my numerator is 1 minus cosine of u all over the sine of u in the denominator. Now, kind of tough here because I kind of have to figure out what am I actually going to do here to get it to look like this. And this trick in this problem is to multiply by a very specific 1, which is something over something, which is going to keep the problem equivalent, but it can actually change inside here to actually help us out. So I'm going to multiply top over bottom by 1 plus cosine of u. And this is going to be something that we're going to see many times in this section, that if we have 1 minus something, that's a little trigger to say, well, why not try to multiply by the binomial of 1 plus something? So in the numerator, we're going to FOIL this out. 1 and 1 make 1. We've got plus cosine u minus cosine u, which simplifies to 0. And then we have the negative cosine u times the positive cosine u, which is negative cosine of u quantity squared. So that is looking really good right there. And then here I'm going to have this as sine times 1 plus cosine u. Now, the reason why I'm not going to actually distribute the sine of u, forgot my u. The reason why I'm not going to distribute my sine of u back into this binomial is because you can see that I want that 1 plus cosine u. It looks like I'm getting closer to my answer. Well, lucky for me, 1 minus cosine squared u is equivalent to sine squared u. And down here, this is sine of u, and then 1 plus cosine of u. Again, glad that I didn't distribute this back in there because the square simplifies with one of the terms down there. So now in the numerator, I have sine of u instead of sine squared u. And down below, this is 1 plus cosine of u. So now it matches what the identity I needed to establish. All right, well, thank you very much for watching our second of 5 videos that cover Chapter 3, Section 4.